Hi everyone. Today we are going to discuss about the international standard atmosphere. We all learned in lower classes what is atmosphere. So here we are discussing, otherwise we are studying about international standard atmosphere. So uh, we know the what is the atmosphere. So here we are discussing what is international standard atmosphere. That means ISA. The International Standard Atmosphere is a static atmosphere model of how the pressure, temperature, density, and viscosity of the Earth's atmosphere change over a wide range of altitude or elevation. According to the ISA model, the layers are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. These five layers we already learned in our lower classes. So here we are going to discuss something more about. Okay, the International Organization Standard ISO published the ISA international standards. Other standards organizations such as ICAO, International Civil Aviation Organization. So the atmosphere from the sea level to above, the temperature, pressure, density, which are the factors affecting to we are segregate the five layers. That are the criteria we are using, that we already told about that, no? Pressure, temperature, density, viscosity of the earth surface. I mean earth surface. So what is troposphere, which is the extending up to 18 kilometers in height? It is the first layer of the atmosphere at the equator and 8 kilometers at the poles. Okay, equator, equator it will become 18 kilometers. At the pole it will become 8 kilometers. So first is troposphere. So now you can see here, here one image is here. So now you can see here. We just find out this image. Now you can see here. This is the image. So that this is the troposphere here. Here it will become the troposphere. So okay. In the troposphere, the temperature decreases with the height. Hence, the density of the air decreases and increases the height. Lesser heat is absorbed. Here we can see the temperature decreases. If it is the elevation is increased from the ground level to top, there is a temperature will be decreased. So density density of the air decreases. Here is the density. If it is goes, we are going to up. The density will become less. Density of the air will become less. So troposphere contain more than 90% of total gases of the atmosphere. Tropo means change, as almost all the weather changes occur in this layer due to the formation of clouds from the water vapor. Tropopause. What is tropopause? You can see here. Uh, you can see here tropopause. This is the tropopause. You can see here tropopause. The maximum height where the temperature stops the decreasing. The temperature here can go as low as 58 degrees Celsius. Okay, this is the troposphere. So next we are going to discuss about stratosphere. This is the second layer of the atmosphere and the range up to 50 kilometers above the troposphere. Out of all the layers of the atmosphere, stratosphere is the most beneficial as it is absorbs the ultraviolet radiations from the sun because of the presence of the ozone as compared to the layer beneath. It is the layer warmer and has a temperature of around 4 degrees Celsius. The layer provides ideal conditions for flying fighter jet plane as it is free from cloud and weather phenomena. Here is you can see here stratosphere, which is the maximum height where the temperature drop decreases. This is the maximum height of the stratosphere layer. That the maximum height will be stratosphere. Then next we can discuss about the mesosphere. Extending to height 80 kilometers above the stratosphere lies the mesosphere. It is one of the coldest layer of the atmosphere, which temperature rising up to 90 degrees Celsius. Meteors burn up in this layer. It is difficult to breathe in this layer as the air is thinnest with bare minimum pressure in it. No aeroplanes, fighter jet, hot air balloons can fly this high to reach this layer. This is the mesosphere, which is the maximum height. This is the mesosphere. Then next we are going to discuss about thermosphere. The thermosphere is founded exactly above the mesosphere with a height 640 km. The temperature in this layer increases with the height as the gas molecules present in this layer absorb the UV. The temperature in this layer increases with the height as the gas molecules present in this layer absorb the UV radiations and the X-ray from the sun. Almost all the layers of atmosphere, this layer helps in long distance communications as the electrically charged gas particles present in this thermosphere reflect back the radio waves from the earth to space. This layer also protects the earth from the huge meteors and satellites. Then exosphere. It is the outermost layer. It is the outermost layer of the atmosphere and extend up to 640 km of height. The temperature of this layer is quite high and ranges between 300 degrees Celsius to 1650 degrees Celsius. As the height of this layer increases, it slowly merges into the interplanetary space. The layer contains the least amount of gases like oxygen, argon, helium, etc. because the particle of the gases escape to space due to bare minimum presence of gravity. This is the final. You can see here. This is the final layer. I mean fifth layer. So which is the distance from Earth to the distance is 10,000 kilometers. It will come almost. So we can atmosphere. We can classify two types of vehicles: atmospheric vehicle. Uh, Atmospheric vehicle as well, which is the vehicle which fly in earth atmosphere only. Then next one is the space vehicle. Vehicle which fly in deep space, like satellites, rockets, like the atmospheric vehicle which is the flight helicopter and something like this, they will come there. So we just discuss about the atmosphere. So we discussed all the five layers, how it will come, what is the difference, temperature difference, and everything what we are discussed today. That we just recall what we learned the previously. So after next classes we are going to discuss about the standards, international standards, why we need ISA. What is the properties of real atmosphere, which is constant or not constant. The real atmosphere property is not a constant. So how we make the standard of standard. So we are going to discuss in next classes about these things. So we create a hypothetical model of atmosphere. As per that, we are make a standards. So thank you for hearing this video. So let me discuss next class detail about the international standards. Okay, thank you.